A 10 kilogram meteor falls from a distance of 2 times 10 to the 7 to 1 times 10 to the 7 meters from the center of the Earth. Use the graph below to determine the change in gravitational potential energy of the meteor. All right, so we are falling from 2 times 10 to the 7, so there. Oh, I should probably use a different color for this one. Let's use green. So from there to 1 times 10 to the 7 to there. Okay? So we want the change in gravitational potential energy of the meteor, so we are looking for the area under that graph. So if we work out, first of all, what each block is worth, so 0.5 times 10 to the 7 meters along the y-axis, so that's just, x-axis, that's there. Okay, so each one of those lines is half times 10 to the 7, and then 20 newtons up the side. And so, what will that give us? 2 times, so 1 times 10 to the 6. No, 10 to the 8, that's even better. Yep. 1 times 10 to the 8. And our units are Newton meters, which are the same as joules. So each block is worth 1 times 10 to the 8 Newton meters or joules. I would say I'd call that 2 blocks. Okay, we've got the first one, which is pretty obvious. It's a full block there. And then if we use our imaginations, this bit can probably fit in there roughly. Okay, so 2 blocks. So total change in energy is going to be 2 times 1 times 10 to the 8. Even I can do this one. 2 times 10 to the 8 joules. Okay, so if it is a force distance graph, remember the area under it will give you the energy change. So that's how much gravitational potential energy we've lost as the object falls. It is also the amount of kinetic energy it has gained. So we're moving faster as it moves closer. All right, any questions there? Yeah. Why do they give you the weight? Because just what I said before. So this red dotted line is the surface of the Earth. So a 10 kilogram object on the surface of the Earth, F equals ma, will have a force of 98 newtons acting on it. If it was a 100 kilogram object, that would have to be 980. So it's just the 10 kilogram, because it's 10 kilograms, that is what makes the numbers in this graph as they are. No, you don't need to use it, but it's just saying that, yeah, because it's 10 kilograms, that's where everything else comes from. But you don't actually need it. You will need it in the next example.